Here's problem 914. A 10-gram bullet moving horizontally with a speed of 1.8 kilometers per second strikes and passes through a 5-kilogram block initially at rest on a horizontal frictionless surface. The bullet emerges from the block with a speed of 1 kilometer per second. What is the kinetic energy of the block immediately after the bullet emerges? So let's take a look at this situation. We have a bullet. Let's call that mass 1. And it's 10 grams, so that's going to be 0.01 kilograms. And it's moving with a velocity, v1 initial, equal to, if I can get this to right, 1,800 meters per second. It's going to encounter a block, and the mass of the block is 5 kilograms, and the initial velocity of the block is 0. So this is the way things look like initially. Finally, the block's going to have a hole in it because the bullet's passed all the way through, and the final velocity of the bullet is 1,000 meters per second. This is mass 1. But the block is moving as well. So there's a velocity to the block. There's a final velocity for the block. We don't know what that is, so we can calculate the final kinetic energy if we knew what that was. And then, of course, this is mass 2. So this is the way things look like finally. Kinetic energy will not be conserved in this collision definitely because it is an inelastic collision. In other words, there are things happening that are taking the energy away, namely heat, sound, collision. We're losing energy due to deformation of the block, that sort of thing. So we definitely will not have conservation of kinetic energy. But as with all these collisions, we will have conservation of momentum. So mass 1, velocity 1, initial, plus mass 2, velocity 2 initial, equals mass 1, velocity 1 final, plus mass 2, velocity 2 final. Conservation of momentum. In this case, velocity 2 initial is 0, so that term is 0. And we have that the mass 1, which is 0.01 kilograms times 1,800 meters per second, is equal to mass 1, 0.01, times final velocity of 1,000 meters per second, plus mass 2, which is 5, times v2 final, which is what we want to find. So we have that v2 final will equal 0.01 times 1,800 is 18 minus 10, all that divided by 5. So that's going to be 8 divided by 5, or 1.6 meters per second. Came out positive, so it's moving in the positive x direction, and the final velocity of the block is 1.6 meters per second. Conservation of momentum is the only way we can find that because kinetic energy is not conserved. However, once we found that velocity, we can calculate what its kinetic energy is at that moment. The kinetic energy, the final kinetic energy of particle 2 is 1/2 its mass, m2, times its final velocity squared, 1/2 mv squared. So this is 1/2 times 5 kilograms times 1.6 meters per second squared. What is that? 6.4 joules. So the final kinetic energy of block 2 after the collision is 6.4 joules. The only way we can find is by finding the final velocity through conservation of momentum. That's our answer.